Hi, we're the green team. I'm Lucas, this is Martini, and this is Emily. And we're presenting our product, Cyclos. Cyclos is an oil filter cleaner that takes dirty oil filters and extracts all the oil out of them, so then the oil and the filter itself can be recycled. So first, we'll talk to you about why we decided to focus on oil filters and why they matter with the environment. Next, Martini will talk to you about our product and its features. Then, Emily will talk to you about the market that we've identified for our product. And at the end, we'll take any questions. So let me introduce you to my friend Stan. Stan's an auto mechanic at a medium-sized auto garage that does about 20 oil changes a day. So Stan's just done an oil change. He's got a dirty oil filter in his hand. And now he's got to decide what he's going to do with that dirty oil filter. He can, A, just toss it in the trash can and let it become hazardous waste in a landfill. Or he could, B, take a screwdriver, punch a hole in the oil filter, and let it gravity drain for 24 hours. Now, neither of these solutions are ideal. But why does that one little oil filter even matter? Well, within one oil filter, there are 8 ounces of oil. And this 8 ounces of oil can contaminate up to 62 gallons of water, 62,000 gallons of water. In the US, every year, 450 million oil filters are manufactured, and 80% of these end up in landfills. But instead, if we recycled these and we reused that oil, we could get up to 255,000 barrels of lubricant and 2 aircraft carriers worth of steel. So let's go back to Stan. So Stan has his 2 choices. When we found out that Stan's decision about what he's going to do with that oil filter really does matter, we decided to give him a 3rd option. That's why we created Cyclos, so that Stan would have an environmentally friendly and easy-to-use way to dispose and deal with his dirty oil filters.
What you're hearing right now is a drill bit going through and drilling a hole into the filter. Now it's retracting, so that the oil can be spun out of the filter. In a little more detail, I'd like to walk you through what just happened. The first step, as you may have noticed, was the clamping. Inside there's a pneumatic that has a nice feature that it can take any diameter or any height of can that can be found in any typical car. So it's pretty versatile. And it clamps it for the entire cycle. The next step is the hole-making process. There are a number of holes that we drill along the filter. And doing this proved to be more of a technical challenge than the team at first realized. It was important that we create exit wounds instead of entrance wounds. Otherwise, we ended up with this inner lip that prevented oil from coming out of the can. It's also important that we didn't dent the filter in as we were punching in, because then you ended up with a problem where the oil flows to the places where the holes aren't, yielding the same problem of no oil coming out. The final step is the spinning. As you noticed, the oil spins, or the filter spins, and the oil comes out. This was also a rather large technical challenge because the oil filter spins at about 1,200 RPM. And when you're talking about these types of speeds with a large mass like an oil filter, it's really important that you get all of these parts precision machined and precision engineered, because any small imbalance can cause the oil filter to vibrate and cause damage within the machine. Throughout the design process, we kept Stan and his needs in mind. As you saw, there's one button operation. All Stan had to do was put the oil filter in and press this green button, and the rest of the process was taken care of by the machine. There are also 3 indicator LEDs so that any user can tell what's happening with the machine. There's a green LED that goes on during the process, and a red one that goes on afterwards that alerts the user that it's time to take out the filter. There's also an LED that indicates that the internal oil storage tank is full and needs to be emptied. In addition, the entire front cover will slide off of the machine, which allows for easy access whenever the machine needs to be serviced or cleaned. And finally, all of the power and hose connections are located in the back corner of the machine. So there's air power, which runs off of the shop air power, as you can see on the side, as well as electricity and a place to empty the oil. It's also important for us to keep sand safe. We have an emergency stop button, a door kill switch, which means that the door needs to be closed in order for the machine to operate. And we also have a locking mechanism in place so that the door cannot be opened during the cycle. Not only is the machine easy to use, it also provides superior performance to the previous method of gravity draining. Cyclos, our machine, can get out 80% of oil, whereas gravity draining only yields about 50% of oil removed from the filter. What does this mean? Well, the EPA has a guideline, or the EPA says that 70% of oil must be removed from filters in order for it to be considered non-hazardous waste. This means that filters processed by Cyclos aren't hazardous, whereas those processed by gravity draining must be processed again at some later point in order to make them non-hazardous. In addition, Cyclos' cycle time only takes 2 minutes, whereas gravity draining takes 24 hours.
Now that Martini has told you why our product is technically superior, I'll tell you why we think we can sell this product. The oil filter recycling process starts in every home when car owners change their oil filters, either by driving them to repair shops or bringing their used oil filters to a collection center. There, the oil filters are drained, and so that the oil and steel components can be shipped off to recycling centers. At the recycling centers, the oil is then re-refined and the steel is recycled. Our product targets the repair shops. We hope to provide them with an easier and faster method of draining the oil filters. Currently, repair shops have several options for draining the oil filters. Most commonly, they use gravity draining, which is a very cheap option because all the shops need is a few drip pans. But this is really impractical for anyone who changes more than 20 filters per day. Larger repair shops can opt to buy a crusher. But at $1,000, the crushers aren't even effective at getting all the oil out of the oil filters. Finally, the auto shops can buy a turbospin. Turbospin is a product that uses a centrifugal technology to spin the oil out of oil filters, but it's priced at $7,000, which means that most auto repair shops can't afford it. So our product, Cyclos, offers a very practical solution to those small to medium-sized repair shops who change between 20 to 50 oil filters per day. At $600, it easily falls within their budget. In fact, we've been in touch with many auto repair shops in the Boston area and throughout the country, and many of them have been very excited about this product that's very affordable to them. In particular, we've been in touch with Good News Garage in Cambridge, and they are very excited about our product because they actually use the used oil in their shops for a heating system. With over 400,000 small to medium-sized garages in the US, we believe that we can sell at least 1,000 machines per year. And at this scale, we can manufacture our machine for $280. This is taking into account material, labor, and overhead costs. And by selling this product at $600, we can get a 30% return on our investment over a 10-year period. And as you can see, we can recoup all of our initial investment within 3 years. So in the end, we have created a product that's very user-friendly and provides a viable business solution, and at the same time, reduce the impact of having hazardous waste in landfills. So we would like to thank everyone who helped us with our project and take any questions that you have.